Here are some selected problems from your homework assignment out of section 9.3, starting on page 495. The goal of this homework assignment is to help you to learn how to identify points of discontinuity and then eventually know how to describe them as either vertical asymptotes, holes, or horizontal asymptotes. So on this first set of problems, you really don't have to get that specific. You just have to basically find out if there are any numbers that would cause the denominator to become 0 if we input that number in for x, and identify if there are numbers like that, just tell us what they are. So I would like for you to, because it's going to be so important when we start graphing, just get into the habit of factoring everything. Like on number 2, I know that I don't get points of discontinuity from the numerator, but if you'll just trust me on this, when it comes to graphing next week, when we meet again, factoring both numerator and the denominator is going to make your graphing quite a bit easier in many cases. So at this point, I'm going to focus on the denominator. And we had this situation come up in class, and if you want to know for sure, maybe you can't see that there are no numbers that you would plug in for x to make 0. If you're not sure, if you do this, if you let the denominator equal 0 and solve for x, you'll notice that you're going to get an imaginary number answer, and anytime that happens, then that tells you that it's impossible to pick a number, plug it in for x, and cause this whole denominator to become 0. Now, you probably could notice that anyway, because even if it's a negative number, when you square it, it becomes positive, and then you're going to be adding another positive number. So there is no way to make this denominator become 0. So therefore, we are going to say that for number 2, there are no points of discontinuity. So that was easy enough. Let's try another one. Well, the first thing that needs to happen is we need to see this rational function in factored form. So hopefully your factoring skills are really good. They're going to be really handy in this chapter. So I factored the numerator, and now I'm going to work on factoring the denominator. There is no GCF. I should look for that right away. You could use the box method here, but really there aren't a lot of options. In fact, for 2x squared, there's only one option, 2x times x. And the only thing we're going to really have to think about is there's the factors of -7 are either going to be 7 and -1 or -7 +1. We just have to put them in the right place. But remember, we need to come up with +5x in the middle after we do FOIL as a check. So it looks like it's going to be like this. I'm going to have +7 and -1. And just do a quick little mental FOIL check. If you do the first terms together, you get 2x squared. The outer terms, -2x. Inner terms, +7x. That does come up to +5x. And then you can see the last terms are -7. So at this point, my focus is only on the denominator. I want to know what are the numbers, and in this case there's 2 different ones that could be plugged in for x to cause the denominator to become 0. In cases like this, 2x plus 7, maybe you can't see what that is just mentally, so you can always do this. Go ahead and let 2x plus 7 equal 0 and solve for x. And you'll get one of your points of discontinuity as -7/2. This one probably is pretty obvious to you. Should be +1. So your answer for number 6, 2 answers really, there's 2 points of discontinuity, and here they are. Okay? All right, now we're moving into the next block of problems, and the directions changed just a little bit. It's along the same idea, but now we need to provide descriptions. What are these points of discontinuity? Are they vertical asymptotes or are they holes? Well, for number 12, fortunately, it's already factored out for us. Let's just determine are there numbers that make the denominator 0? There's two of them. For this first binomial, negative 3/2 would make 0. Again, you could let 2x plus 3 equal 0 and solve. We have another point of discontinuity at x equals 1, but don't stop there. When you get to 10 through 18 even, you need to go ahead and name these. And remember, in class we said that if these numbers only make the denominator 0, not the numerator, then they're considered to be vertical asymptotes. So for this problem, I have two vertical asymptotes. X equals negative 3/2 and x equals 1. Number 18, a little different story. I'm going to have to do some factoring. So I'm going to factor the numerator and the denominator. I want you to do the same thing, show that in your work. But a little bit different here because we've got options for 6x squared. Is it 6x and x? Is it 3x and 2x? So I think I'm going to use the box method for this, and this is a good little review of the box method. Pretty easy to do. First term here, last term there, multiply those together, and then think of the factors of negative 12x squared that add up to positive 1x. I would put positive 4x and negative 3x. Now find GCFs, 2x and negative 1, 3x and 2. So that's my factoring. 2x minus 1, 3x plus 2. Okay, and you could check that out with FOIL if you want to make sure. Looks like 4x minus 3x is positive 1x minus 2. That looks good. Okay, now let's think about factoring the denominator. Well, in this case, when there's really only one option, in this case for 3x squared, our only choice is 3x times x, then I'm not going to bother with the box method. I just have to make sure I put the factors of 10 in the right place so that I'll get 17x in the middle. Well, this would make 15x on the outside, which means that this must be 2x in the middle. Okay, now let's focus on the denominator. That's your first thought. What are the numbers that make the denominator 0? And there are two of them. Negative 2/3 is one, and negative 5 is the other. Okay, my next question then to myself is, do either of these numbers also make the numerator 0? And the answer is no. If they did, then that would be a whole. So in this case, these numbers only make the denominator 0. So we have vertical asymptotes at both places. Oh, I'm sorry. I'm not paying attention. I am sorry. We have one vertical asymptote. You probably recognize that. You're thinking, what in the world is going on? Do you notice that negative 2/3 makes 0 here? Yep, the same number that made this 0 on the bottom made that same binomial, 0 on the top, obviously it's the same. Don't know why I didn't see that before. Wasn't paying attention, so we have a whole here at negative 2/3 because that same number made both bottom and top become 0. All right, sorry about that, but that is your answer for number 18. Okay, just in case, I hope if you're one of those classes where we really ran out of time before I had a chance to talk through this little chart, you should have already watched the video of the lesson. This should already be in your notes. But I wanted to put it up here, run through it one more time real fast. When you're trying to determine horizontal asymptotes, one of three things are possible. You need to understand how to find the degree of the numerator and the denominator. That's what this means, N and D. For this first example, the degree of the numerator is 2, the degree of the denominator is 1, and so obviously the numerator degree is bigger. If that's true, then we will not draw any horizontal asymptote on our graph. If the degrees are the same, then we saw this in class, we're going to make a fraction out of the lead coefficients. So notice the degree of the numerator is 1, so is the denominator. In this particular case, my horizontal asymptote would be the line y equals -2. Okay, that's what this means. Just make a fraction, top coefficient over bottom lead coefficient. Okay, letter C shows a degree of 1 on the numerator, degree of 2 in the denominator. When this happens, numerator degree is less, then it's always the same line. You're going to draw a horizontal asymptote on top of the x-axis. So just quick little review. And now let's apply this thinking on these last problems, 20 through 24. So checking out the degree of the numerator, it's 1. The degree of the denominator is 2. So the bottom is bigger. Okay, remember what that means. When the bottom is bigger, or in this case I've said the numerator is less, then the horizontal asymptote will be the line y equals 0. So that's your answer for number 20. All right, number 24. The degree of the numerator is 1, so is the denominator. So we have this case where they are the same. We're going to make a fraction out of the lead coefficients. All right, so it's like this. I'm just going to draw a circle to indicate what my horizontal asymptote is. My horizontal asymptote will be the line y equals 3/4. Okay, so I'm not going to do any other problems, but I just wanted to reiterate on 25 through 28. I know the directions tell you to graph, but I want you to hold off. I want you to find all the necessary information. Okay, so basically you're looking for, are there any horizontal asymptotes? If so, where are they? Do you have any vertical asymptotes? If so, where are they? Are there any holes? If so, where are they? And I just want you to write that down, okay? Don't do any graphing yet. We're going to gather all this information, and then we're going to apply it on Tuesday when we start actually doing the graphs, okay? So that's all I have for you in this homework assignment. I hope that helps you with the rest of the problems. If you have any other questions, let me know.